Hello scholars, welcome back to our live CSEC class. Tonight we're going to be looking at algebra. We're doing an introductory class, and we're going to look at the terms used in algebra, explaining what each term means, and so you know when you see them what to expect, right? What are you supposed to do? All right, so get your book and your pencil ready to take notes. I want you to always have your book and pencil or pen for the older guys who have graduated from the pencil, except to do your graph and stuff, right? Always have your material ready to take your notes. And even if we might be moving a bit fast, you don't have to get word for word. That's not how we take notes. We don't do it word for word. What I want you to do is to jot down the important points. All right, so I'm just going to share the link. Just give me a second. Let me share the link so others can join and benefit from our introductory algebra class. All right, so I have a number of groups that I religiously share the link. So join. All right. Now, I just wrapped up the PEP ability class, and Amari was asking me, by the way, welcome Amari and John and Imani, welcome. You are the first scholars on tonight. So Amari was asking me what my favorite topic in math was, and I was telling him that it was algebra, and it still is algebra. So I'm really excited tonight to be introducing you to my absolutely favorite topic. Now, the subtopics that we're going to be covering in algebra, let me just run down quickly so you just brace yourselves for what we're going to be doing. So welcome scholars. When you come on, remember to say good evening, miss and fellow scholars. Let us big up each other and follow the protocol, right? So we say good evening, we hail up each other, just like how you'd go in the face-to-face class. You would say good evening. Okay, who did I just share this link with? Oh, okay. All right. So I'm just getting this link out. All right. So that's. All right. Okay, students. So I was saying the topics that we're going to be doing in algebra would be simplifying. We'll start with simplifying expressions. We do subtopics like factorizing expressions, solving algebraic equations and inequations, simultaneous equations, both for two linear equations and one linear and one nonlinear or quadratic. we'd be looking at which other topics we have in algebra. Linear programming is an overlap between algebra and graph, and you'll find in math several of the topics overlap each other, and you can actually use several methods to solve the same problem, which I love to show my students that you're able to do that. Right, so those are some of the topics, and we'll do them step by step. All right, good evening, scholars just joining, welcome. So in our class today, it's an introductory class to algebra. And we're going to be looking at the terms. Hi, guys. I'm just seeing the fingers. Come on. You're a guest in my studio. I don't want to just see fingers. Okay, so let me see those beautiful faces. All right. Are you weren't ready to be on the screen? You're going to be ready tomorrow?
Yeah, say it again.
Yes. You're good?
Yes,
Okay.
miss. Yes, miss.
All right. Welcome on the screen, my guests. So we're going to look at some algebraic terms. I'm going to explain to you, and of course, I want some feedback from you if you're not understanding. Hi, Jaden. All right, so I'm going to share the screen now. Hopefully this goes easily. All right, so I'm seeing this stuff. I'm still finding my way around. So that's the PEP session that we just wrapped up. So now we're at Introduction to Algebra. All right. Let me make sure my screen sharing. Okay. All right. So my screen is being shared properly. All right. The first term is equation. We talk a lot about algebraic equations, solving them, simplifying them. What is an equation? So an equation says that two things are equal. And that's the root word, equal. That's how we get equation. It will have an equal sign. So for example, 4x plus 9 equals 4. Negative 3y minus 7 equals 36. So we're saying the terms on the right are equal to the term on the left, or the terms on the left. You can have any number of terms on the left or the right. And what we do to equations ultimately is to solve them, to find out what is the value of the variable in that equation. In the case of simultaneous equations, where we would have more than one variables and more than one equations, so we will be solving for each variable in each equation, right? So you're saying this is equal to that. That's what an equation is. For our next definition, a variable. What is a variable? The root word here is vary, which means to change. It doesn't always stay the same. It's not always equal to the same value. So a variable is a symbol for a number that represents an unknown quantity, or rather it should be a symbol or a number that represents an unknown quantity. It is usually a letter like X or Y or N, but actually any letter or symbol can be used. You can use a star symbol, a circle, a triangle, an asterisk, a head, a foot, a car. Any symbol can be used to represent the unknown quantity. When we're doing topics like substitution, we give actual values for the variables. So we're saying substitute this value for this variable. But the values change. As you go along, you might see, okay, in this question, let x be -3. You go down the line and you hear them say again, in this question, x is 0 or x is 5. So it still changes. Even when they are giving you the value of the variable, the fact is it is a variable, so it doesn't keep the same value all the time. It has infinite number of values, and that depends on the situation that it finds itself in. So we're saying we don't know, sometimes we don't know the value of a particular amount. So for the time being, we use a symbol, a letter, a shape, just to represent that amount. And ultimately in algebra, we want to know the value of that amount in that given situation. All right, so let's go to the third definition. And this is a number by itself without a variable attached to it is called a constant term. So for example, in the expression 6x plus 7, that's an expression, the number 7, so the number 7 is the constant term. The 6x is a term that has a variable and a coefficient. The variable is x, the coefficient is 6, and we'll get to coefficient in just a second. So right now we're talking about the constant term. So that 7 is by itself. It's not attached to a letter. It's not attached to a variable, like how the 6 is attached to the x. Usually when we are writing our expressions or even our equations, we have a standard way of writing it, and we would put the terms in descending order. So the terms with the highest power would go first, and then, consequently, the lower, then the lower. And the constant term, it's not that the constant term has no variable, it's that it's actually, the variable has a power of 0. So we could write 7x to the power of 0. That's the same as writing 7, because any number or term or variable raised to the power of 0 is 1. So 7x to the 0 power is the same as 7 times 1, which is 7. So we don't bother to write the x to the 0 power. So it would be incorrect to say it doesn't have a variable, or the variable doesn't have a power. It's just that it's x to the power of 0, which is 1, so we just write the 7. All right? So we put the terms in descending order. So here we have the 6x term where x is to the power of 1. So that would come before the 7 with the x to the power of 0, which is a constant term. But we generally just ignore the variable to the power of 0, and we just focus on the number itself, that constant term. All right, now let's go to the next definition, and that is the coefficient. A coefficient is a number used to multiply a variable. So for example, 12y means 12 multiplied by y. So 12 is a coefficient. It could have been negative 12y. It could have been 3x squared. So in the terms, in the case of 3x squared, the coefficient will be 3. If it's negative 4y, then the coefficient will be negative 4. The negative or positive goes with the number. So we don't separate them. Negative 5xy, the coefficient is negative 5. Now, variables on their own without a number next to them actually have a coefficient of 1. So x is really 1x, and negative x is really negative 1x. So if the term is positive or negative, so it's a 1, the coefficient is 1 if the term is positive, or it is a negative 1 if the term is negative. And something students make errors in. Good evening, Rona. Good evening, Christopher. Hi, Christopher. Hi, Anusha. Welcome back. Anusha was just in the PEP class, and she's back for the CSEC class. Hi, welcome all scholars. All right, so this is something that a lot of scholars make mistakes with. That x is really 1x. They forget that negative x is really negative 1x. And so when they are simplifying expressions, they forget to add that 1. So for example, if we have 3x plus, they think the answer is just 3x, or they might even write square. Both of them correct. So we would have to add the 3x to the x, and we would get 4x. Likewise, if we had 10y minus y, we would have to remember that it's 10y minus 1y, which is 9y. So even though we're not expected to write the 1 or the negative 1 in front of the variable, just bear in mind that if you see the variable without a number in, there is actually a 1. It's just that we don't have to remember it's there, especially when you are simplifying your expressions or your equations. Also, when you are factorizing, so when you're factorizing, so for example, if you're pulling an x out front, it's just 1x in the expression, you would have to x goes 1 time. You're actually dividing the 1 by the 1. So those kinds of things you have to understand in terms so that you don't make any errors with your factorizing or your simplifying. Let's go on to the next term. And remember, scholars, I want jotting these, even if you don't get them word for word, and you have to get yourself into the habit of taking notes without having to write word for word. Jot down the important points. All right, so now we're at the operator. An operator is a symbol such as plus, multiply, divide, add, etc. that shows an operation. The symbol of the operation tells us what to do with the terms. So the basic arithmetic operations are multiply, divide, add, and subtract. Those are the basic arithmetic operations. So when we are given our expressions, the terms are separated by, let's say, an addition or a subtraction. The operation tells us what to do with the terms. we have something called the order of operation, which governs the order in which we work out or arrange or group the terms. So the order of operation, some persons know it as BODMAS or BOMDAS or PEMDAS. What it really means is we work certain things first before we work the other things given an expression or equation. So we if there are brackets or parentheses, we work what is in the brackets first. If anything is being raised to a power, we sort that out first, and then we deal with the addition, the multiplication and division, and finally we add and subtract in the order that they were given. If you do it randomly, you are going to get a different answer, and more than likely it will be an incorrect answer. So if you work out your subtraction and addition before your multiplication and division, or if you work out things outside the bracket before first sorting out what's in the bracket and raising things to the power first and getting those bigger guys, those more powerful guys out of the way, and then you simplify using the addition and subtraction in that order, and taking note of your negative signs as well, because those are tricky sometimes. And we're going to be covering all of these subtopics as we go along so that you can master every part of it, right? But just bear in mind, there is something called the order of operations. All right, so moving on. So now we're talking about terms. A term is either a single number or a variable, or numbers and variables multiplied together. Terms are separated by operators to form expressions or equations. An expression is a group of terms. The terms are separated by plus or minus signs. So for example, if I say 3x plus 5y minus 6, those are three different terms. The 3x is a term. It has a coefficient of 3 and a variable of x. The 5y, the minus 5y is a term. Y is the variable and negative 5 is the coefficient. And then the 6 is a constant term. So terms come together to form expressions. And then when we have an equal sign, it becomes an equation. Or if we have an inequality sign, which we'll get to in a minute, it becomes an inequation or an inequality. So 5 by itself is a term. That's a constant term. Negative 3x is a term. 5xy to the fourth power is a term. So terms are, they're either standalone or they combine, they multiply with variables and powers. And then we combine terms with plus or minus to get expressions. And then we can even make those further into equations or inequations. All right, so now we're looking at the exponent. Another word for the exponent is power or index, and the plural is indices. An exponent, such as the 2 in x squared, that little 2 at the top, or x cubed, that little 3 at the top, those are exponents. It says how many times to use the value in a multiplication. In other words, how many times we multiply the number by itself Another name for an exponent is a power or index, the plural of which is indices. So a common mistake that scholars make, so for example, when they see x squared, they think it means the same as 2 times x or 2x. If they see 6 squared, they would multiply the 6 by 2. No, that's not what it means. The power tells you how many times you're going to multiply that base number by itself, not by the value of the power. So 6 squared doesn't mean 6 times 2, it means 6 times itself, 6 times 6. And 4 cubed, or 4 with a little 3 at the top right hand corner, 4 to the power of 3, it doesn't mean 4 times 3, it means 4 times itself, 3 times. So that's 4 times 4 times 4. That's how we work exponents. Remember, another name for an exponent is a power or an indices. All right. So you will hear the name polynomial. So polynomials are terms that, or expressions that have several terms, right? Some of the terms can be constants, some can be variables, some of the variables can have exponents, and we factorize polynomials, we expand them using the distributive law, we simplify them. Factorizing and expanding, you could say they are opposite to each other, and we're going to dive into all of those as we go along. Simplifying refers to the process of putting like terms together. And we're going to talk about like terms in a second. So the poly, remember the root word poly means many. So the polynomial is an expression with many terms. Now, you can also have monomial, binomial, trinomial, and so on. So the monomial, remember, mono means one. So the monomial has one term, for example, 4x, that's a term. The binomial will have two terms. So in 4x, the 4 is the coefficient and the x is the variable. And together they make the term 4x. Negative 9y plus 6 is a binomial. It has two terms. In the negative 9y, the negative 9 is the coefficient and the y is the variable. The 6 is the constant term, which we could also express as 6y to the power of 0. Just bear that in mind. Always bear that in mind. Y to the power of 0 is 1, so it's just 6. The trinomial now has three terms, and we can have, as polynomials can have many, many terms. But at this level, you're likely to see up to 3 or the most 4 terms in your polynomials. But just bear in mind, you can have any number of terms. So in this trinomial, we have 24xy plus 5x minus y. So the first term is 24xy. The 24 is the coefficient. X is a variable, y is a variable. In the 5x term, 5 is the coefficient, x is the variable. In the negative y term, -1 is the coefficient and y is the variable. Now, if we were asked to simplify the trinomial, group the like terms together, what would we have as a result? Can we simplify that trinomial? The 20 plus 5x minus y. Can we simplify that? What will be the final answer? Let me hear some thoughts on that. Can terms together, what would be the result of that? Let's see some quick answers, students. All right, nobody wants to try this one. Would we add the 4 to the 5 and then take away 1? Remember, we said that negative y is really negative 1y. So would we say 24 plus 5, 9, minus 1, give 28. And then the x plus the other would give 2x. And the y minus y would give 0. Is that how we would do it? Amari is saying, no, miss. No, miss. Amari is saying we can't group them because they are all different terms. And he is absolutely right. And Imani is saying the same thing. So these are known as unlike terms. We're going to talk about like terms in a minute. These are all different. Even though the 24xy, it has an xy, but we can't add to the 5x. It will be 5xy for us to add it. Same for the y. We can't take y from xy. xy is different from y. There are two differences. So the 24xy plus x minus y, that's as simple as we can make that expression. It's in its simplest form. We can't add or subtract those terms. So you are sharp. Just wanted to test if you guys were on top of things, or if you were going to make the mistake and think that you could combine terms. So let's look at, I think the next slide is talking about like terms. Right, okay. So like terms are terms whose variables and their exponents, such as the 2 in x squared, are the same. In other words, terms that are like each other. Note the coefficients can be different. We can only add and subtract terms that are like. We can multiply and divide unlike terms, right? So we can multiply if the terms, those 3 terms that we saw a while ago, if it was a multiplication sign between them or a division sign, we could have canceled if it was possible to cancel, or multiply the coefficients and multiply the variables. So x times x would give us x squared. X times y would give us xy, and the negative y times y would give us negative y squared. We could multiply them, but we couldn't add them. So for us to add or subtract the terms, the variables including the powers, have to be the same. So you can't add x and x squared, or you can add x squared and x cubed. Or if you have xy squared and x squared y, those are two different terms. The variables and powers have to be exactly the same. When they are exactly the same, then you can go ahead and add the coefficients and write back the variables. So you're not going to add up the variables, you know. So it's like you would say 3 apples plus 4 oranges. You can't add apples and oranges. They are different fruits. You can't. So it's a similar concept. All right. The next slide. So this is giving the difference between expressions, equations, and inequations, which are also called inequalities. So remember, we said the expression, it does not have an equal sign. It has any number of terms separated by plus or minus. So 10y plus 3x squared minus 9p, whatever, any number of variables, any number of terms and powers separated by plus or minus. That's an expression. When we put an equal sign and say all of that on the left is equal to this on the right, then it becomes an equation. For the expression, we can simplify it if it's possible. We can factorize it, but there's nothing to solve because it's not equal to anything. When it becomes an equation, now we can go one step further and solve it. If it's a simple linear equation with one variable, then we have a simple way of solving that. If it has more than one variables, and if there are more than one equations with the same variables, we can use simultaneous equations and solve them. There is also a method in matrices that we can use to solve them. And matrices is one of the topics that we're going to be doing. We can use graph to solve them. There are graphical methods we can use to solve equations. And this is the beauty of maths. We can use so many different methods from so many different topics to solve the same problem. Now, the inequation does not, or the inequality, it doesn't have an equal sign. What it has is an inequality sign. And that inequality sign can be the greater than sign, the less than sign, or you can have greater than or equal to, which is the greater than sign with a line under it, or it can be less than or equal to, which is the less than sign with another line under it. So those are called inequalities, and the methods for solving inequalities are pretty much the same as for solving equations. There are some exceptions, and we'll get into those when we're actually doing the, but pretty much they are the same methods. All we can use graphs to solve inequations or inequalities. Those are the main algebras that we're going to be using to use the proper term for the thing. If you're talking about a variable, I want you to say the variable, coefficient, the exponent, the index. You must know the proper name for things. And I always tell my scholars that if you understand the language behind the words, the terms, even though you're doing mathematics, if you understand the language of the maths, it will make it that much easier for you. So when you see a word, try to think, what is the root of it? What does the root mean? Because the same way that regular words are derived, this is how mathematical terms are derived. The meaning of just equation, the root is. And so knowing the meanings of the words will help you to understand the concept behind the mathematics. So I my scholars, my math scholars, to always have their dictionary. And somebody would say, doing maths, what do I need a dictionary for? Yes, you absolutely need it, because any word that you see, for example, when I am introducing simultaneous equations to my students, the first thing I ask them is, what is the meaning of the word simultaneous? And they have to get out their dictionary and tell me, if they don't know offhand, what does simultaneous mean? Why do we call these simultaneous equations? So simultaneous means occurring at the same time, two or more things occurring at the same time. And we call these simultaneous equations because we're solving two equations at the same time. We're solving two variables. So immediately it's clearer to you. Now, the two methods that we use for solving simultaneous equation are the substitution method, the elimination method. Again, I ask my students, out your dictionary, what's the meaning of substitution? What's the meaning of the word elimination? Why do we call this method the elimination method? Why do we call this substitution method? To sub means to put one thing in the place of another. So we make one of the, since it's two variables we're dealing with, we make one of them be the subject, and then we substitute that value into the other equation. Eliminate, what does it mean to eliminate? To get rid of, to cancel out. It's no longer. So in the elimination method, we take certain steps to eliminate one of the variables, to get it out of the time being, so we can focus on the other variable and solve it, and then we bring back the first variable. So when you know of the words, even though you're doing mathematics, certain aspects of it is language based. And as a matter of fact, when you're doing paper 2 questions, I want you to write out your answers in a way that the examiner can see the logic. So at points you're going to actually statements. I am doing this because now there are that we can use instead of writing out entire sentences. There are mathematical symbols, but I still want you to be making mathematical statements. So don't forget the language and think that language is not a maths. Absolutely. And the more you can be familiar with terms and the language behind the terms, the original words, you will be better able to grasp the concepts in mathematics. Now we're going to wrap up this session, but I want to schedule. Some of you scholars are new to our channel, and you might not yet be familiar with our schedule of live CSEC classes. So I'm going to read that for you, and you can jot down the time and the days so that you won't miss any. Also, remember, you should turn on notifications. Just click that bell so you'll be notified in case you even forget. In case you write it down and then slip you somehow, whenever we go live, don't miss any of the live sessions. So the schedule for the live CSEC class is weekly. So every week, 5 days to Friday. I'll soon answer your question, Amar. All right, so on Monday is 8 to 9, and we do graphs. Tuesday, 8 to 9, and this is PM. Wednesday, 8 to 9, we do topic. So we'll do a topic different from algebra, specific days, and we'll explore that. When it's over, we'll do another topic. On Thursdays, we're going to focus, same 8 to 9, we'll focus on the formulae, how they were already run, some shortcuts that take in solving your problems without having to go from scratch all the time. But you should be able to work your formulae from scratch if you understand the concept behind them. So we have 2 classes on Thursday. There is a midnight class on Thursday, midnight to 2 a.m. And that will be in our Midnight Oil series. That's the name for the series, the Midnight Oil. We're going to burn the midnight oil. And we're going to be doing the paper 1 CSEC. So when you're finished with the formulae class at 9, you go straight to bed and you set your alarm to wake you up at 10 minutes to 12, and you go wash your face, drink some water, and present yourself for the midnight class. And on Friday from 6 to 8, we do the CSEC paper 2. So we're covering all hours. We're making sure that we have classes for every aspect of the math exam. The paper 1, the paper 2, you must be proficient in graph. Algebra is featured heavily in CSEC, so you must be proficient in algebra and you must know your formulae, and then we're going to do the other topics, topic by topic. So we're covering all our bases. All right, so Amari, you're asking me what I think is your weakest subject. Your weakest subjects. I don't know, Amari. I guess I would say the bio because you're new to it. I think you like it, but because it's a new thing to you, you probably need to put some more time in it. But you're very good at the language subjects, and you're pretty good at maths. You think it's special. But Amari, aren't you always coming somewhere near the top in the spelling quizzes? Anusha says her parents go to bed. so she can't. So you're saying you can't come to the midnight class because mommy and daddy will be asleep? Maybe if you ask them nicely, Anusha, they'll set up just that one night. Just ask them nicely. I'm sure when they see that you're very interested in staying for the midnight class they'll set up with you, man. Are there any questions regarding the algebraic terms before we wrap up? Do you understand all the terms? All right, Amari, well, you'll have to work on your spelling then. Look at your spelling rules. And this is something you can work on your own, you know. You can sharpen up those skills on your own. Okay, all right, so you understand the terms, and this is very important because as we go further in the algebra classes and I make reference to these things, I want you to know exactly what I'm talking about. And this is why for the first live class, I decided through the terms so you know. So when I say coefficient, you know what I'm talking about. When I say variable, you know what I'm talking about. You know the difference between expression, equation, inequation. So when this class is over, and you can always watch this video again and again until you are proficient in your terms. Scholars, I want to thank you so much for being a part of this class. You are the reason why I do this. I absolutely love my job. I love teaching. And I love getting you to, especially as we emphasize math because so many people struggle with math. And I want you to know that you can master this, you can be proficient, and you can enjoy it. That's the important thing, to enjoy learning maths. So if you'd all just say goodbye, just type bye. Let's wish each other goodbye. You can say it any way you want. You can say goodbye. You can say until next time. You can say good night. You can even use up your Jamaican terms. You know, remember Jamaica within it. I'm gone, I'm a bed. I'm gone, who want to type that? Let me see how you spell it. I'm gone, I'm a bed. All right, guys. Goodbye. It was a pleasure being with you, and I'll see you tomorrow.